Hi guys, welcome back. In this tutorial we will see how we can use the ADC module with the continuous sampling. So we are going to use timers and a PPI module for taking samples continuously, and we will save them in the buffers, and then we will retrieve these buffers and we will calculate these values. So first of all we are going to see how we can do that. So if you haven't seen my previous tutorial, please watch that first, because we are going to continue that from the previous tutorial's code. So today we have this code opened, and it's from the previous tutorial in which we configured our SAADC module for single shot, and now we are going to configure it in the continuous sampling mode. And to take the continuous samples continuous, we are going to connect a timer via PPI module, and today I will be using timer 1, because timer 0 is mostly used in the soft device when we are using the Bluetooth. So be sure you use timer 1 and make it a habit of using timer 1 and timer 2 and other timers, but don't use the timer 0, because it's going to be used for the Bluetooth communication in later tutorials, and if you try to use timer 0 you are just going to receive some errors. Okay, so first of all you have to configure the timer. So go on the SDK config, right click on the CMSIS configuration wizard, and here in the CMSIS configuration wizard we have to enable the timer. So go into the drivers and expand this, and here in the timers click on the timer 1 and enable it. I have already enabled it, that's why it's checked, and you should also enable it, and also go in the legacy drivers and enable it from here as well, otherwise it won't work. So enable it. I have already configured it, so it was enabled previously, so please be sure to click on this to enable the timer, otherwise you won't be able to use it. So this is a very common mistake among the beginners. So click on the save, and it's saved. Now we can use the timer 1. So first of all we are going to create an instance of the timer 1, so let's start it. And this time I'm going to initialize the timer 1, so timer instance 1. And we also need to initialize the PPI module, so for that I'm going to I've named it PPI channel, so we will use this for enabling the PPI once we allot the channel. So for timer we have to create the empty handler, because we cannot pass any null value to the timer. So let's just create an empty handler for first, because the event is already connected with the SAADC sample so task, and we are not going to use this handler, but we have to at least initialize it, otherwise we have to pass this handler, otherwise it's going to give us an error. Okay, we have created a handler. Now we need to create a function which is going to initialize the timers along with the PPI and configure everything for us. If you don't really know how we are using timers with PPI, you can take a look at this playlist and find my tutorial for the PPI. In that I'm explaining how the PPI module work, and I have already explained how we can connect timers with the PPI. So here we are just going to use the same technique. So first of all we have to initialize the PPI module, so make sure it's initialized only once in your code. Next thing, we need to configure the timers. For that we have to create a configuration. Let's name it as timer config. Let's initialize it with the default configurations, and let's set the timers bit to 32-bit. I'm just making sure that we can use the timer for long periods. Now we have to pass this configuration and initialize the timer. Pass the address of the handle timer, which is the timer 1. Pass the configuration address, and we have to pass the timer handler. I'm just going to add the timer handler here. Okay, the timer is initialized. Just need to check if some error. Now we are going to create a variable which is going to save the tick values. I'm just going to name it as ticks, and so I'm just going to pass it the function which is going to calculate the tick value for us, milliseconds to ticks, and I'm just going to pass it the timer handle, which is timer, and the number of milliseconds. So let's say after every 50 milliseconds this is going to take 5 samples, we will receive the event, and in that event we are just going to calculate the values. And the first thing will be the timer handle. Second parameter is the channel, so we are going to use the channel 0. We have to pass the number of ticks, so I'm just going to use this ticks variable, and then we will pass this. And now we will enable the timer. Now we need to calculate the addresses and save them in some variables so we can pass them to the PPI module. So I'm going to create 2 variables which are going to hold these addresses. Let me name it as timer compare, and I will get this and I will get this from this function. Second would be the sampling task. Because we have only one ADC, so it's just going to call this function is just going to give us the task address for the ADC. Next thing we need to do is we have to allocate the channel to the PPI, and we are going to assign it the PPI channel. So it's automatically going to see which PPI channels are available. It's going to automatically allocate this channel. And the last thing we need to do is we have to connect the timer's address with the sampling task, so that whenever the timer event is generated, this sampling task automatically gets activated, and this task is performed, so we don't need to call any function. So basically this is automatically doing all the stuff. Okay, the PPI channel has been configured, and the timer is also configured. We just need to initialize the PPI and timers in the main function. So I will just copy this, and after initializing the SAADC, I'm just going to paste it here and initialize the timers and PPI. Now the timers and the PPI is initialized and everything is set. Only one thing to do is we have to remove this nRF5 SAADC sample, because now we don't need it. The timer will automatically do that for us. It's just going to call this task automatically, and we are free to do anything here. So we just need to connect the PPI channel so that the SAADC can start receiving the events. So to do that, I'm just going to use this simple line of code. PPI channel enable, and I'm going to enable this channel. We have already enabled the timer, so be sure you have enabled it, otherwise you won't be seeing these interrupts for the timer. The event is not going to generate if the timer is not enabled. Okay, our code is set and done, so let's build this code. I hope so there is no error now. Okay, the code is built, everything is set. So I'm using the light dependent resistor LDR. So basically the LDR has the resistance, and its resistance increases with the decrease in the light intensity, and vice versa. So if I go to the target, I click on the connect, and then I will erase my device and click on the download. After every 50 milliseconds an interrupt is going to be generated, and in that interrupt the SAADC is going to take these samples and copy them to the buffer, and then the buffer is read through this callback handler, and we show all the data to our user via UART and nRF log info. So to show the data, I'm just going to use the putty, and my COM port is 6 connected with this device. Make sure you connect with the right COM port, otherwise you won't be able to see your data. And the baud rate is 115200. I will open this, and here you can see the timer is generating interrupts after every 50 milliseconds, and in those 50 milliseconds it's taking 5 samples and giving us these 5 samples at a time. So if I move this a little closer to the light, and you can see there is some change in the readings, and if I move it away from the light, you can see the readings are changing. And if I put my hand in front of it, if I put my finger in front of it, you can see the readings have drastically changed, because a lot of light is being blocked by my finger. So this LDR is giving more resistance, and hence we can see this change in the value, and it is reflected in terms of voltage by this module. So I hope so you have learned something new today, and this is the continuous sampling, and you can use it with the low power modes, and it's going to work really well. And right now we know everything about the SAADC. Hope so you have learned a lot of stuff from this, and this code and the functions detail are all available for download in this in the description of this video. So be sure to check them out and play around with the code. If you are new to my channel, please be sure to subscribe to my channel and hit the bell icon to get the notifications of new videos on time. Thank you very much for watching. See you in the next video.